Okay, today we're moving into chapter 5, and we're going to look at some problems from section 5.1. And our topic today involves rational exponents. So specifically, we're looking at exponents that are in the form of a fraction. And so remember that the denominator, the bottom number, is the root, the top number, the numerator is the power. And so using our rules of exponents, because we're multiplying, we can distribute. If this was a sum or difference, we could not. So we can take each term and raise it to the 3/2. So here with 81 to the 3/2, the denominator 2 means to take the square root. So I'm not going to write this out for every problem, but just so we understand, that's really what it's saying is that take the second root of 81 and then cube it. So that's 9 cubed. And here we have our power raised to a power, so we can multiply. So that gives us r to the 18 over 2. 9 cubed is 729, and then we get r to the 9th. So applying that here, 64 to the 7th sixth, r to the 18th to the 7th sixth. I'll do this one more time just to demonstrate. So we're talking about here the 6th root of 64 raised to the 7th power. And here I'm not going to multiply the 18 and the 7. I'm going to simplify by dividing first. So 6 divides into 18 3 times, and then 3 times 7 is 21. So the 6th root of 64 is 2. And then 2 to the 7th is 128. So we get 128r to the 21st. Okay, so moving along here, we have 125 to the 5/3 n cubed to the 5/3. Cube root of 125 is 5. Here, the 3's divide out. We get n to the 5th. And we get 3125 n to the 5th. And over here, 625 to the 5/4, n to the 4th to the 5/4. 4th root of 625 is 5. Here, the 4's divide out, so very similar problem. 3125 n to the 5th. Okay, so here we're just writing these in radical form, so similar to what we were doing up here. So the denominator is the root, the top number is the power, so we have the cube root of m raised to the 2nd power. And over here we'd have the 6th root of v raised to the 7th power. Okay, let's look at a couple of other problems here. Now we're writing this in exponent form. So again, root and power. So 10b, that would be raised to the 5/4. And over here, there's no number here in the root, so that means it's a square root. So this would be 3b raised to the 5/2. Okay, and finally we have a couple equations to solve. So just like all other equations, we're going to isolate their variable, or at least most other equations, right? We're going to subtract 10, divide by 5. Now to undo the cube root, we're going to cube both sides. So again, notice power raised to a power, 1/3 times 3, there's x to the 1st, and 2 cubed is 8. Okay, over here, we've already isolated the expression with our variable, so we're going to raise it to the reciprocal power of 3/2, or rather of 2/3, which is 3/2. And the reason we do that is our power to a power rule, we're going to multiply. And anytime we multiply any number of times, it's reciprocal, that equals 1. But what we have to take into account here is that we are taking an even root of an even power. So just like earlier in the year, one of our big topics, square root of something squared, which is what we're doing here, means we get the absolute value of that quantity. And over here, the square root of 16 is 4. 4 to the 3rd is 64. And so now we have an absolute value equation. And we set that equal to the positive and the negative. And we end up with 35 and negative 93. Okay, one last one. So again, we've already isolated the expression with the variable, raise it to the reciprocal power. And notice, even though it's not a square root, it is a fourth root, but it's an even root of an even power. So that's going to give us the absolute value. And then here, the fourth root of 625 is 5. 5 cubed is 125. And so now to solve the absolute value equation, again, we set it to the positive and the negative. And we end up with 25 and negative 25. Okay, hope that helps, and we'll see you soon.